Hello, my name is Bruno Shola Tungimana. I am a biochemistry senior in Dr. De Guzman's class, and I'm here today to talk about my research on the effects of 5-hour energy short on glycogen phosphorylase B. It is titled Know Your Enzyme, The Surprising Effect of 5-hour energy short. I hope to both shed light on the role that glycogen phosphorylase B plays in our bodies, and most importantly, examine the effect of 5-hour energy short on it, which is a caffeine-dominated energy short that has soared in popularity on campus. Glycogen phosphorylase B is an enzyme that catalyzes the breakdown of glycogen into glucose 1-phosphate, which can be used for energy or converted to glucose 6-phosphate for other metabolic pathways. Glycogen phosphorylase B is a multi-subunit enzyme that has two conformational states, relaxed and tense. The relaxed state is more active and has a higher affinity for the substrate, while the tense state is less active and has a lower affinity for the substrate. Glycogen phosphorylase B has several binding sites that regulate its activity and kinetics. A catalytic site to the substrate and the cofactor of pyridoxal phosphate bind, an inhibitory site where glucose 6-phosphate binds and stabilizes the tense state, an AMP site where AMP binds and stabilizes the relaxed state, a glycogen site where glycogen binds and enhances the activity of the enzyme, and recently discovered allosteric site where caffeine and other compounds bind and modulate the enzyme. In Figure 1, I highlighted the AMP binding site and the allosteric site where caffeine is bound. Adapted from a paper by Matthew et al., Figure 2 depicts how the AMP binding site is located at the interface between two subunits of glycogen phosphorylase, which means that AMP can affect the interaction and alignment of the subunits. When AMP binds to the site, it causes some structural changes in the enzyme, such as the movement of helices and loops that allow the enzyme to switch from the inactive tense state to the active relaxed state. The relaxed state has a higher affinity for the substrate and a lower sensitivity to inhibitors than the tense state. Therefore, AMP binding increases the activity and efficiency of glycogen phosphorylase B. To examine the effect of glycogen phosphorylase B in vitro, we conducted an enzyme assay where glycogen phosphorylase B activity was measured by monitoring the release of inorganic phosphate from glucose 1-phosphate. The glycogen phosphorylase B was species was sigma aldrich and was purified from rabbit muscle. The reaction was initiated by adding glycogen phosphorylase B and incubated at 25 degrees Celsius for 10 minutes. The reaction was stopped by adding 0.5 ml of 10% sulfuric acid, and the amount of inorganic phosphate released was determined by the molybdenite method. The standard curve for inorganic phosphate was used to determine the concentration of inorganic phosphate in a sample. This is done by measuring the absorbance of a sample and comparing it to the calibration curve created using known concentration of inorganic phosphate. The AMP assay is consistent with current literature, as we witness a drop in Vmax as the concentration of AMP increases. We noticed a rise in Vmax as the concentration of AMP increases, as it is an activator. Lastly, our data on 5-hour energy shows mirrors that of AMP. The Vmax drops as the concentration of 5-hour energy short increases. To conclude, our study implies that 5-hour energy short is beneficial in boosting energy as it prevents the breakdown of glycogen and preserves it as a source of energy in the muscle for later use. To improve the accuracy and reliability of the assay, we plan to use mass spectrometry or HPLC to quantify the inorganic phosphate levels with a higher sensitivity and specificity, since the molybdenite method is known to produce inconsistent results due to the instability of the molybdenum blue complex. Lastly, I would like to thank my lab partner Braden Huslik, my TA Sahida Nasiri, and the immense mentorship of Dr. De Guzman. This work would have not been feasible without them.